Hello explorers and welcome to another video. Today we are doing the Advent of Code puzzle. The Git repository is linked in the description below, and if you want to see all of my trials and tribulations, you can see the full recording as a member of this channel. So let's get into it. Day 4. Let's kick in here. Day 4 camp cleanup. Space needs to be cleared before the last supplies can be unloaded for the ships. And so several elves have been assigned the job of cleaning up sections of the camp. Every section has a unique ID number, and each elf is assigned a range of section IDs. However, some of the elves compare their section assignments with each other, and they notice that many of the assignments overlap. To try to quickly find overlaps and reduce duplicate efforts, the elves pair up and make a big list of section assignments for each pair, your puzzle input. For example, consider the following list of assignment pairs. For the first pair, it is a list means within the first pair of elves, the first elf is assigned sections 2 to 4, sections 2, 3, and 4, while the second elf is assigned sections 6 and 8, section 6, 7, and 8. The elves in the second pair were each assigned to 2 sections. The elves in the third pair were each assigned 3 sections and got the section 3, 8, 6, and 7, 5, 6, and 7, while the other also got 7, 8, and 9. Okay. This example list uses single-digit section IDs to make it easier to draw. Your section list might actually contain larger numbers. Visually, these pairs of sections assignment look like this. Okay. Some of the pairs have noticed that one of their assignments fully contains the other. For example, 2 to 8 fully contains 3, 7, and 6 is fully contained by 4, 6. One other elf in the pair would be exclusively cleaning sections their partner will already be cleaning. So these seems like the most in need of consideration. In this example were 2 such pairs. How many assignment pairs does one range fully contain the other? We have 2 numbers and we need to figure out which have so there are 2 such pairs. So that's the answer, I guess. And let's save this file then. See if we can get 2 pairs of the puzzle input. Day 4. And I have already prepared this little file here so we can run these directly. So what we want to do is read this in and get some ranges, and then probably the second one will be something totally different. So let's start with a line here. We will split it on that, so we will have elf. Do like that, simplify things, and these are 2 strings. Elf assign. And so we have 2 elf assignments, and we want to compare those 2, so we need to figure out how to read the other ones. So we could do a bunch of if statements here. We could do another split. String assign 1 equals to elf assign split by dash. So that would be those two. We can do the same for 2. And then the if statements would be to pick the 2 values. One low. So this one would be as integer parse int assign 1 0. And then we will have 1 high. Then we do the same for the second one. So now we have 2 values. If assign 1 low is lower than assign 2 low and lower or equal to, and assign 1 high is higher or equal to assign high 2, then we will count this like that. Int count, and then we'll do a count as out, so print it out. So let's try this and see if we get 2, or if we have totally misunderstood we got 1. Well, 1 is pretty close. Let's go and see what's going on here. So first off, we have the first pair. So it gets assigned here. And if we look at the lows and the highs, they should not be counted, right? So which ones are the ones that should be counted? These 2, right? Yeah. So we need to have the other way as well, like that. Then we should have 2. Yeah. So now we have 2. If we go over to the other example, we might already have a solution for this. It's a little bit, kind of a lot of code, but I think it's more readable this way. So let's switch over here and see if we got the right result. So 709. No, you're not right. The answer is too high if you're stuck. Okay. So let's see that we have an else statement here, so we don't have both cases at the same time. So we had a bunch of them there that were identical. And that... Yes! You get a gold star, I get a gold star, everybody gets a gold star. So that was the problem. We had a bunch of them that were identical. So let's see here. Part 2. It seems like there is still quite a bit of duplicate work planned. Instead, the elves would like to know the number of pairs that overlap at all. In the above example, the first 2 pairs, 2, 4, 6, 8, and 2, 3, 4, 5 don't overlap, while the remaining 4 pairs, 5, 7, 7, and 9, do overlap. So in this example, the number of overlapping assignment pairs is 4. How many assignment pairs do ranges overlap? Now we just need to see if we have overlapping things, which means that the high should not be no overlap count. So we have a different count here. So let's figure out when we need to do this. And no overlap count, we can print that out as well, so we have 2 numbers there. If we have assignment low and that is above assignment to high, then we have one case here that do not overlap. And else, if we have assignment too low is larger than assignment 1 high, then we also do not overlap, right? How many do we have then? We have 2. So let's think about this. So that one overlaps. That one overlaps. That one overlaps. What? They said that 4 doesn't. The number of overlapping assignment pairs is 4. How many assignments pairs do ranges overlap? Okay. So we found 2 that doesn't overlap, which means that we have 4 that do. All right. So if we do it like that, we should have 4, right? What? Ah, we need another plus, of course. So now we have 4. So those are the ones that do not overlap. Is that as simple as the solution for this problem? We have 62 that do not overlap. So we have 938 that overlaps. Could be. Let's see. Yeah, you get a gold star. I get a gold star. Everybody gets a gold star. That was not very unexpected, actually. Well, it makes sense, but it was easier than I thought it would be. So the thing I did here was pretty much see that we have count where we don't have an overlap, and then just count all of them and then subtract the number that overlaps, that don't have an overlap with the ones that have an overlap. So if the low value of the first pair is, or the first assignment is higher than the high value of the second assignment, and the low value of the second assignment is higher than the high value of the first assignment, then we have no overlap in them. And then we can just subtract it with all of them. So today's little thing was pretty simple. And yeah, I hope that you learned something today. I hope that you found this interesting. If you liked this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. If you have any comments or suggestions or have written your own code, please leave it in the comment section down below. I really like to see other people's code and figure out how they solve this. And I really hope to see you in the next one.